Hello guys. Welcome back to another video. This is Tridenour Science. What is a black hole? Why are black holes so weird? How are black holes formed? What are your thoughts on these questions? Comment below. A black hole is a region in spacetime where gravity becomes so strong that no matter, and even electromagnetic radiation could escape from it. Black holes were first theorized by Albert Einstein in 1916 through his theory of general relativity, which predicted that, if mass is packed sufficiently dense, then it could deform spacetime and form a black hole. But such high densities of mass are present only inside a core of huge stars. Black holes are formed due to the gravitational collapse of a dying star. When a star runs out of the nuclear fuel inside its core, the outward pressure generated by the energy released during nuclear fusion reaction reduces. As a result, the equilibrium between the inward gravitational pull and outward pressure is disturbed and the star collapses rapidly, resulting in a supernova explosion. In this supernova, almost all the mass except the core is exploded into the space. All stars do not form black holes, it depends on the mass and density of the remnant core after supernova. The stars like our Sun do not form black holes, instead they form white dwarfs. A white dwarf is the stellar remnant of a dead star whose mass and density were not sufficient enough to form a black hole. The electron degenerate matter inside prevents the further collapse of these white dwarfs. Only the stars whose mass is less than 8 solar masses forms a white dwarf. In 1931, Subrahmanyam Chandrasekhar, using the special theory of relativity, and calculated that, above a maximum mass limit, which is 1.4 times the solar mass, the white dwarfs are no longer stable, and they collapse further due to their immense gravity to form neutron stars. The gravity is so strong that the electrons and protons inside the core are fused together to form neutrons. Hence the name neutron star. These neutron stars are formed by the stars whose mass is in between 8 to 15 solar masses. Neutron stars are fast-spinning high-density objects in the universe. They have such a huge magnetic field that they can alter the atomic structure. But in 1939, Robert Oppenheimer and others predicted that neutron stars above another limit, the Tolman-Oppenheimer-Volkoff limit, would collapse further for the reasons presented by Chandrasekhar, and concluded that no law of physics was likely to intervene and stop at least some stars from collapsing to black holes. The current value of the limit is around 1.5 to 3 solar masses. The defining feature of a black hole is the appearance of an event horizon, a boundary in spacetime through which matter and light can pass only inward towards the mass of the black hole. Nothing, not even light, can escape from inside the event horizon. The event horizon is referred to as such because, if an event occurs within the boundary, information from that event cannot reach an outside observer, making it impossible to determine whether such an event occurred. As predicted by general relativity, the presence of a mass deforms spacetime in such a way that the paths taken by particles bend towards the mass. At the event horizon of a black hole, the deformation in spacetime becomes so strong that there are no paths that lead away from the event horizon. To a distant observer, clocks near a black hole would appear to tick more slowly than those further away from it. Due to this effect, known as the gravitational time dilation, an object falling into a black hole appears to slow down as it approaches the event horizon, and takes an infinite time to reach it. At the same time, all processes on this object slow down from the viewpoint of a fixed outside observer, causing any light emitted by the object to appear redder and dimmer. This effect is known as gravitational redshift. Eventually, the falling object fades away until it can no longer be seen. Typically, this process happens very rapidly, with an object disappearing from view within less than a second. On the other hand, observers falling into a black hole do not notice any of these effects as they cross the event horizon. According to their own clocks, which appear to them to tick normally, they cross the event horizon after a finite time, without noting any singular behavior. If somehow, the observers cross the event horizon, it would not be able to avoid them being carried into the gravitational singularity, the region in spacetime where the curvature becomes infinite, and can be thought of as having almost zero volume. When they reach the singularity, they are crushed into infinite density and their mass is added to the total mass of the black hole. But before all this happens, the observers are torn into pieces. Because the difference in the tidal forces, at even a small distance like 10 centimeters, is in the range of thousands to millions. This process is referred as spaghettification or the noodle effect. Once a black hole is formed, it starts feeding on the surrounding interstellar gases, or even stars. The masses of the gas or stars is accreted around the black hole and forms so-called the accretion disk. The velocities of particles in this disk are so high, that the temperature near the event horizon reaches millions of degrees. This accretion disk forms a strong magnetic field around the black hole. Because of this magnetic field, beams of charged particles with high kinetic energy are emitted from both the poles of the black hole. The black hole collectively with the accretion disk and the beams of charged particle form a quasar. Quasars are one of the brightest cosmic entities in entire universe. They are so bright that they can even outshine the entire galaxy. And so guys, this is it for this video. But this is not the end of our journey in exploring the black holes. Join us in the part 2 of the black holes video, in which we explore more about some of the interesting features of the black holes and other information. There is so much more for us to learn and become better. So be curious and imaginative. Thank you for sticking around, and we will be coming back with more fascinating things in the universe for you to learn and be amazed. So stay tuned. Please like and share the video, and subscribe to our YouTube channel to get notified whenever a new video drops. Please follow us on Instagram and Twitter. Up to then, goodbye.